All right, friends, number 12, page 436. It says, determine the slope of the terminal arm for each angle in standard position. So basically, you're given this angle, 10 degrees, and you want to know what the slope is. The slope is rise over run, right? You know nothing. It's not giving you anything. It's a little bit of a trick question. Pick a number. Doesn't matter. Now, based on kind of the earlier video from today, we're talking about unit circle. You can just make that 1. You can make it 1,000. You can make it 13.9 if you want. Doesn't matter, because based on that, you're going to get a relationship between these two. So they're called trig ratios. You're going to get a ratio of these that's going to give you your slope. So if this is 1, let's say I want to solve for, this will be the opposite side. Sine of 10 equals the opposite side, so let's call that y, over the hypotenuse of 1. So it's just going to be sine of 10. Going to be a decimal because I'm using my calculator. So 10, the way this calculator works, I have to hit the number first, 10, and then sine 0.1736 equals, not equals, y equals 0.1736. Now if we want to get the adjacent side, I'm going to use the cosine. So cos of 10 equals x over 1. So it's going to be cos of 10. X equals 10 cos 0.9848. 0.9848. Slope is rise over run. The rise is 0.1736 and the run is 0.9848. So 0.1736 divided by 0.9848 equals 0.1763. We round it. Very close, obviously. This is the slope. Curious what it has actually in the back for these. This is 12A. 0.2. Yeah, okay, so it's rounded to 0.2. Like I said, it doesn't matter what you would use for the hypotenuse. I was also asked to do question number 14. I figure I'm just going to keep these all in one video. Make my life easier. Maybe yours, maybe not. Number 14. Oh, okay. It says, explain why the following statements are true between 0 and 90 degrees. Cos of 90 degrees minus theta equals sine of theta. So in other words, it's like cos of 40 equals sine of 50. Cos of 10 equals sine of 80. And so on. Now, the idea here is just kind of the relationship. Now, I shared that unit circle video earlier today talking about the unit circle. When you have an angle, so with the unit circle, let's look at the unit circle for a second. So when you have, let's say, whatever, let's say that's 40 degrees. This is going to be a certain value of your y height. This is going to be your x, so it's x, y. As this thing moves, maybe I'll do a different color. So it goes up. It goes up. This one shortens, and then this one lengthens. These ratios are going to stay the same based on the hypotenuse. If this one gets shorter, this one gets longer, and these are complementary angles, and that's the relationship they have. It's kind of like with that 30, 60, 90. If this one was for a, let me do it this way. I'll do it here. This is tough over video. When you have a 30-degree angle, this is going to be a half. This is going to be root 3 over 2. When you have a 60-degree angle, this is going to be root 3 over 2, and this is going to be a half. I don't know that I'm doing a very good job explaining this. Play with it. Now that you know that this is true, play with this. See if you can make some meaning from it. It's good to, you won't have to, I'm not going to ask you to kind of articulate the why or the how, but you should know that it's there. This will come with knowledge of the unit circle. Don't stress on this particular one. Hopefully that helps.